So today we talked about graphing using slope-intercept form, y equals mx plus b. Let's talk about a few pieces. We have m, which we know is our slope, and we have our y-intercept. We need to identify both of those if we're going to be able to graph. And I want to talk about what each of these features are. Let's start by finding the y-intercept. If we look at our problem over here, we have a -2. That means that is our y-intercept, since b equals -2. Let's start by graphing the point 0, -2. So I start at the origin. 0 for x tells me I do not count left or right, but -2 on the y tells me to place a point right here. Let's talk about the slope. Slope tells me how I am going to angle my line. It helps me figure out, is my line going to be a steep slope or is it going to be a shallow slope? Meaning, is it going to be tall and hard to climb up or short and a pretty breeze of a walk? So let's take a look at what our slope tells us to do. We have a +7 on top, meaning I'm going to start at my point and count up. 1, 2, 3, 4, 5, 6, 7. And then +2 means 1, 2 to the right, giving me a coordinate right here. So that tells me that after I count it up and count it over, that my line is going to have a pretty steep slope. Once I have these down, I'm going to create a line that goes through both the points. And I apologize, on this video, they are not going to be absolutely perfect. I'm using our Smart Notebook program, and it can be somewhat difficult to graph. But that line is an example of what we are trying to do. Notice I took it off the chart, and I put arrows on the end. It does not have to be as far off as this end. I suggest just a little bit past it, as you see at the bottom. Let's take a look now at number 2 here. B equals 3. So let's start by graphing the point 0, 3. Start at the origin, go up 3, and I have a point right here. Now let's look at the slope. M equals -6. Now slope is always a fraction. Not only do we go left to right, but we have to go up and down. Our -6 tells us we are going to count down 6, but we need something to tell us whether we go left or right. Anytime you have a whole number, in order to turn it into a fraction, just go and divide it by 1. When we divide it by 1, it now preserves the number 6. -6 is still my slope, but now it gives us all the numbers we need to count. To start, -6 tells me to count down 1, 2, 3, 4, 5, 6, and then to the right, a +1 right here, giving me this coordinate. What we see here, it's a negative slope, and after moving those pieces, it has pushed our line over just a little bit to give it a nice steep slope. I know I am using terms you might find a little comical, I'll be honest, but I want to make sure we understand what slope is really showing us. We're talking about the steepness of a line. Now, I suggest, after looking at these two examples, take a look at number 3. It's a tad different, and we haven't seen this before. We've talked about these type of lines, and what we should note is this is still slope-intercept form. If you recall, a line that is in the form of y equals some number, it is going to be horizontal. So let me take a look. We could have a y-intercept. We still have a y-intercept. B equals -5. So graph the point 0, -5. Now about that slope. A horizontal line is just straight left and right. And if we talked about in terms of slope, what happened was we don't have to count up or down, giving the 0 on top, and on the bottom, we could pick any number left to right, let's say 2, which gave us a slope of 0. So when I plugged it into the equation, y equals 0x minus 5, I want you to note what happens when you do 0 times x. In the end, it would be just 0, takes it away. Anything times 0 is 0, it's gone. Y equals -5, the equation we're starting with. Now, since our slope is 0, we don't count up or down any direction, but we could count left to right any number we want, place a point, and make sure we connect our dots. If you recognize that this is a horizontal line without all of this, that is okay. This is just here to help if anyone is getting stuck on those kind of lines. You don't have one of these in tonight's homework. Algebra 1 does not have this in their homework tonight, but it's one that if I gave it to you, I'd want you to be able to understand. Now you can pause this and give number 4 a try on your own, but I will go ahead and fill that in. So pause it now if you'd like to try it. And let me go ahead and fill it in. We have y equals 6 over 5x plus 1. So plus 1 means my y-intercept is here. And for my slope, I must count up 6, which is going to be a little bit off the graph. 1, 2, 3, 4, 5, and right about here at the arrow. And then we'd count over 5. 1, 2, 3, 4, 5. I'd have a point right about here. If it's difficult because the point is off the graph, we could always work backwards. One of the things I want you to notice about slope, we don't have to use just 6 over 5. We could use -6 over -5. That is because when we have a negative on top of our fraction and a negative on the bottom, they go to cancel each other out, leaving me with just 6 over 5. So we could instead use this fraction and graph the points at -6 and then -5. 1, 2, 3, 4, 5. Giving me a point right here. Let me mark this one again. And if we draw our line, you should see that it actually will still pass through the line I had up top, giving me these two ends. There's another example I want to talk about here, and that is going to focus on number 6. X equals 5. What I want you to remember about x equals 5 is that it is, I'm sorry, x equals 5 is a vertical line, meaning it's going to go straight up and down. That 5 is an important number. Since it is a positive 5 and we're talking about x equals -5 means that my vertical line is going to cross through the point where the x is 5, meaning right here. X equals 5 means an x-intercept of 5. And then all you'd have to do is draw a line straight down. Just that simple. If we ever run into those, I'm going to direct you back to this video if you have any struggles. Now, one more part to this. These were all in slope-intercept form. But what happens if we have an example that's not in slope-intercept form? I'm going to flip the page to more examples. And we're going to look at examples that are written in what we call the standard form. Remember that the standard form is when we have ax plus by equals c. In number 1, we have 7 is our a, we have a 1 for our b, and then 5 for our c. But we want to rewrite the equation 7x plus y equals 5 in such a way that y is by itself. I want to get y all by itself. To do that, I got 2 steps for you. First, add or subtract the term without y. Meaning, we have a positive 7x, so I want to subtract 7x on each side. I would get y equals -7x plus 5. Now there is a reason why I wrote it in that order. Note that the 5 in the original equation was positive, so I could put a plus sign in front of it. But since I want to take my equation and put it in the form y equals mx plus b, I want that x term to be the first thing after the equal sign. Now, I would have a second step, which would be to divide by the number in front of y. But we got lucky this time. That was a 1. And when I divide by 1, nothing changes. So I now have an equation in slope-intercept form. This is my slope-intercept form. Now let's pull out the pieces. We have that our y-intercept, b, is 5. So I need to graph the point 0, 5 right here. And now my slope is -7 or -7 over 1. So I'll count down. 1, 2, 3, 4, 5, 6, and 7. And then over a positive 1, giving me a really steep graph. A really steep graph. And connect dots. Followed by our arrows. Now I'm going to pick an example where I'm going to have to actually divide at the end. So if you need to, pause right here and take a look at example 1. But I am going to actually scroll over to example 2 and address what happens when we actually have to do the division step. So over here for number 2, I want to follow the exact same steps I was working on. I need to add or subtract the number in front of x and then divide the number in front of y. This time, we're going to be dividing by 5. We'll start by subtracting 3x I'm left with 5y equals negative 3x. It was a negative 5, so minus 5. Again, I want that x term to be the first thing after the equal sign. Next, let's divide by 5. And now, the way you saw it today, they wrote the whole thing divided by 5. But I want you to be careful. That does mean that I have to divide not only negative 3x by 5, but also negative 5 by 5. And if that is not clear, I could rewrite this as negative 3 divided by 5 with my x, and then minus 5 divided by 5. The great part about this is once we simplify everything, I get an equation that looks a lot more like the equations in slope-intercept form. Y equals negative 3 over 5x minus 1. So let's go ahead and graph our pieces. We have a y-intercept of negative 1. So on the y-axis, I'm going to put a dot right here at negative 1. Now let's do our slope. The negative 3 on top tells me to go down 1, 2, 3, followed by the 5, which tells me to go to the right because it's positive. 1, 2, 3, 4, 5. So here's another point. Now I did ask that you guys try to put as many points as possible, at least 3. So let's go back, starting from our y-intercept, and see if we can't fit another point. We're going to go backwards. By backwards, here's what I mean. I'm going to start at that negative 1, and instead of going down 3, I'm going to go up. 1, 2, 3. Instead of going to the right 5, I'm going to go to the left. 1, 2, 3, 4, 5, giving me my third point right there. Look closely and you will see that these points are all in line with each other right here, meaning we did good on our graphing. This will help with the graphing portion of our homework. There were some questions where you were given a graph with 2 points and had to create the equation. We can talk more about those together in class, but right now the biggest skill is I need to be able to give you a graph and you can find the equation. Or I can give you the equation and you can identify which graph it matches. At any point, feel free to pause this, rewind back, and focus only on the questions that you need.